Alright, now we've drawn a scatter graph and we've talked about how I could have made a better sentence, but I've sort of talked about TASGOO in very, very minimal detail. Just a brief overview. In your assessment, you'd be expected to go tell me why you'd expect it to be linear or whatever. Do a little bit of research behind it. Why would you expect? Yeah, why would it be negative? Why would the speed of the river slow down as it gets deeper? Would you expect it to be linear? Would you expect it to be strong? And why? What happened to that outlier? You might find a little bit of information about it. But at this stage, we're just going to move on to the formula. Here's a formula here. Velocity is equal to whatever that says. A whole lot of numbers here. I've just taken the liberty to type it out for us down the bottom here. I've also typed the R value. The R value can tell you a few things as well, which I'll touch on this video. Alright, so a formula, velocity is equal to negative. That negative here just says that the slope is going down. If it wasn't negative, it would be going in the upwards direction. Negative, yeah, I don't like saying these numbers. You could round this if you like. There's quite a lot of digits for what you're actually doing. Times, this equation has a star, I've just put an x. So times the depth plus that number there. Alright, so one of the things you're going to have to do is actually try and explain that in context. I've again taken the liberty. You could write something along the lines of, as the river gets deeper, the velocity tends to slow down. So it goes from bigger numbers to smaller numbers. That'd be alright. Let's go in a little bit more detail. We've got a little formula here. What does that number mean? Well, that number means that's the gradient. If the river gets deeper by 1 meter, I'm taking 1 meter just because that's what it means, it's just a rate. If it gets deeper by 1 meter, then the velocity slows down because it's negative. That would be, if it wasn't negative, it would be speeding up. So as it gets deeper by 1 meter, it slows down by that number. I decided to round it, and I put meters per second. I don't even know the units. It's a terrible graph, but if that were the units, that's how much it would be slowing down by each meter of depth. If you want, sometimes this number here would make a little bit of sense. Kind of doesn't in this case. So this would be saying that if the velocity was 0, maybe it makes sense. If the depth was 0, then the speed would be 1.8 meters per second. But that doesn't make sense in this case because if the depth was 0, then there'd be no water flowing. That's just silly. So you have to make a judgment call whether you use that number. With that number, you're basically looking at if the whatever your explanatory variable is, in this case depth, if that was 0, that's what that could be. They got an R value here. The R value, there's another little video, or there's other videos around to explain the R value. Basically tells you how strong the relationship is. Negative means it's going down, positive means it's going up. Closer to 1, the closer to 1 it is, the closer these dots are to the line. If it were 1, then they'll be all on the line. If it were, and we can sort of have a little range of values. I've got a little bit of range of values at the bottom of these notes. R values, if it's between 0.9 and 1, you can consider it a very strong trend. This one would be very strong. If it's between 0.75 and 0.9, you can consider it strong. 0.5 and 0.75, you can consider it moderate. Between those two values, you consider it weak, and below that, you would say no or little association. I got those values from an ESA workbook. Anyway, That was the graph, or that wasn't, doesn't have to be was. That is the graph for my untitled document. Happy studying.